since 90 nanometers, which 10 years ago was the main technology, voltage really hasn't scaled anymore. There's sort of a 1-volt wall.
Yeah, that's it.
And what we've addressed is, how do you go through that wall? So why don't people continue to lower the voltage? There are a couple of reasons. One of them is variability. Basically, we're literally at these atomic layers, levels where atoms matter.
Right.
The number of dopant atoms in the channel is so small that these statistical fluctuations cause fluctuations in the turn on and off voltage of the transistor. So something as simple as an SRAM starts to become unstable at less than a voltage because 1 or 2 of the bits are out of sync when you have millions of them. So one of the problems people have to solve is the variability. How do we make things close and identical enough that we can keep lowering the voltage and they're going to function? Another of the issues is performance. As it used to be, when the transistors got smaller and smaller, you could lower voltage and still keep the field strength high enough that transistors went fast. But as that voltage, as these dimensions have shrunk, there's a problem with how do you make them fast, yet at low voltage.
You mentioned that the first spin or the first iteration of this approach starting in 2006 wasn't going to have much commercial appeal. How did you transition when you came in 2009 from that approach to today's SuVolta approach?
Right, so when we came in, it was an approach based upon silicon on insulator technology, and a different type of transistor called a JFET. And so there really were 2 problems. Or the most basic problem, it was so different from the way things are done today that literally the inertia of the system wouldn't change enough to make that doable. And then there were some technical issues too. Now, when I came in with Scott Thompson had found a technical solution, but it was still our opinion that since it wasn't close enough to the current ecosystem, it would again be too hard to be adopted. But there was the eureka moment, how to take Scott's solution to solving the technical problem, which was the variability in the other device, and how that could be inserted in today's bulk planar silicon solution. That gave a solution to both problems, so that something that can be inserted relatively easy into today's existing structure, completely compatible with the design ecosystem and the fabs, yet solve this variability problem and low voltage performance problem.